Hey everyone, welcome to the channel. In this video, I'll talk about a fun little infinite series. But before I discuss the details of the series, I would like to share an interesting anecdote associated with this problem. Dutch mathematician Christian Huygens gave this infinite series to Gottfried Leibniz to find the summation of it. This is obviously a very simple problem for someone like Leibniz's caliber. He solved it very easily. But at that time, Leibniz had an inflated sense of his mathematical ability. So he visited England in order to publish this result and impress all the English mathematicians. But after going there, he found out that a mathematician named Pietro Mengoli already solved this series almost 2 decades earlier. He also slowly began to realize how less he knew about mathematics. So he came back to Europe and started serious study of mathematics under Huygens, and the rest is of course history. He was one of the co-discoverers of calculus along with Isaac Newton. But this problem was significant for another reason. While solving this problem, Leibniz encountered an idea that later worked as an inspiration for him in developing integral calculus. We will see what that idea was within a few minutes. Now let's go back to our problem. This infinite series is basically the sum of the reciprocals of the triangular numbers. For those of you who don't know what a triangular number is, triangular numbers are the numbers that can be expressed as the summation of the first few consecutive positive integers. They are called triangular numbers because we can express them in a triangular form in the following way. Now the summation of the first n positive integers is n multiplied by n plus 1 over 2. I showed a visual proof of this identity in one of my previous videos. In case you didn't watch it, I'll put a link in the description box below. Now, as the triangular numbers are the summation of the first few positive integers, for example, we can express 1 as 1, 3 as 1 plus 2, 6 as 1 plus 2 plus 3, and so on. The nth triangular number is the summation of the first n positive integers. If we denote the nth triangular number with Tn and the summation of the first n positive integers as Sn, we have Tn equal to Sn equal to n multiplied by n plus 1 over 2. So the denominator of each of these terms are triangular number. That means we can write the nth term of this series, which is any arbitrary term, as 1 over n multiplied by n plus 1 over 2, which is equal to 2 over n multiplied by n plus 1. As we already established that the nth triangular number is n multiplied by n plus 1 over 2. So the summation that we have to find can be written like this. In case you are not familiar with this notation, this is basically the summation notation. This is a shorthand for the summation of all the terms from the first term to all the infinitely many terms. Now maybe some of you have seen on the thumbnail that the sum of this series is actually 2. But knowing that is of course not enough. We have to show why this is the case. I'm going to solve this now, but as this problem is comparatively simple, I will encourage you to pause the video right now and think about it for a while. If you can do it by yourself, you will have the bragging right of solving the problem that was once solved by Leibniz, which is pretty cool. The tool that I'm going to use to solve this problem is called telescoping method. Telescoping method is an extremely powerful tool in solving problems related to series, both finite and infinite series. In one of my previous videos, I solved a series using telescoping method where I also discussed a little bit about that method. However, I am not very satisfied about the way I explained it, so I am going to talk about it here again. But still, if you want to have a look into that video, I will put a link in the description box below. Consider this series t1 plus t2 plus t3 up to tn. This series will be a telescoping series if we can express the general term tn of this series as the difference of two consecutive terms of a sequence. If we can do this, something magical will happen. All the terms of the sequence will be cancelled out except the first and the last term. So the sum of the series will be an plus 1 minus a1. This method of expressing the terms of the series as the difference of two consecutive terms of a sequence is called telescoping method. We will try to do the same thing with our series. The general term, that is the nth term of our series, is 2 over n multiplied by n plus 1. How can we express it as the difference between two other terms? Well, we are going to use partial fraction decomposition to do this. As the denominator of this term is the product of two factors, n and n plus 1, we can write 2 over n multiplied by n plus 1 like this: a over n plus b over n plus 1. If we solve this partial fraction decomposition by doing some routine calculation, we get a equal to 2 and b equal to minus 2. That means we can write 2 over n multiplied by n plus 1 as 2 over n minus 2 over n plus 1. So we can write the first term, which is 1, as 2 minus 1. We can write the second term, which is 1 over 3, as 1 minus 2 over 3, and so on. If we rewrite our series like this, all the terms will have a positive and a negative counterpart, except the first and the last term. So all the terms in the middle will be cancelled out, and the only terms that will be remaining are 2 minus 2 over n plus 1. This is the summation of the first n terms of our series. But in our case, our series is an infinite series. So what happens when n is infinity? Well, as you can see in the following table, as n is getting bigger and bigger, 2 over n plus n is getting extremely closer and closer to 0. You can also see it in the graph of 2 over n plus 1. Here x-axis represents n and y-axis represents 2 over n plus 1. As you can see, as n is getting bigger and closer to infinity, 2 over n plus 1 is getting closer to 0. You can imagine if n gets even bigger, even closer to infinity, then after a while 2 over n plus 1 will be so small that we can consider it to be 0. So we can write 2 minus 2 over n plus 1 as 2 minus 0, which is equal to 2, which is our desired answer. This idea of finding the value of a function at a particular point by finding the value at the points closer to it is called taking the limit of the function. We could have formally written our result like this. This is just a shorthand mathematical notation. It basically means as n approaches infinity, 2 over n plus 1 approaches 0. Limit is a central idea in all of calculus. Leibniz used this idea of limit later to come up with the idea of integral calculus. How did he do it? Well, I'll talk about it in a different video. For now, I have another problem for you to solve by yourself. Try to find the summation of this series. Of course, you can do it using mathematical induction, but try to do it using telescoping method.